This second lecture video on motion will discuss acceleration. Acceleration is a change in velocity per unit time. To find the average acceleration, we will take the change in velocity or speed, depending on which is given in the problem, and divide by the elapsed time. We will use the letter A to abbreviate acceleration, delta V to represent the change in velocity, and T to represent the time. The change in velocity simplifies to v sub f, or final velocity, minus v sub I, or initial velocity. The basic equation that allows us to solve for acceleration is change in velocity is equal to the acceleration times time. The units we will typically see for acceleration will be feet per second squared or meters per second squared, since velocity is typically feet per second or meters per second, and time is in seconds. If we have a constant acceleration, that means for every second that passes, the acceleration is the same. In this case, we have a constant acceleration of 4 meters per second squared. This means that for each second that passes, the car is traveling 4 meters per second faster than in the previous second. This car has a constant acceleration of 4 meters per second squared. If there's a constant acceleration, the speed is increasing. That means that the distance traveled per second will also change since the speed is increasing. Let's take a look at an example with a constant acceleration. You are driving out of town and the speed limit changes from 25 miles per hour to 55 miles per hour. Find your acceleration in feet per second squared if it takes you 5 seconds to accelerate. First, let's write down all of the information we are given. The initial velocity is 25 miles per hour and the final velocity is 55 miles per hour. The time it takes to accelerate is 5 seconds. In this problem, we are trying to find the acceleration. We will worry about our units in just a minute. The basic equation is delta V equals A times T. The working equation, where we rearrange to solve for A, is that A is equal to V sub F minus V sub I divided by T. Before we can substitute, we need to make sure all of our units are consistent. Since we have time in seconds but velocity in miles per hour, we need to convert both of our velocities to feet per second. To do this, we will take 25 miles and write it as a fraction over 1. Then we will use a conversion factor that 1 hour is equal to 3,600 seconds and 5,280 feet is equal to 1 mile. Multiplying, we see that the initial velocity is 37 feet per second. Since our initial velocity only has 2 significant digits, our converted velocity will also only have 2 significant digits. Next, we can go through basically the exact same conversion for 55 miles per hour. So we will write 55 miles over 1 hour and use the conversion factor 1 hour is equal to 3,600 seconds and 5,280 feet is equal to 1 mile. This gives us a final velocity of 81 feet per second. Now that we have the units we need, we can substitute into the working equation. 81 feet per second minus 37 feet per second divided by 5 seconds gives us an acceleration of 8.8 feet per second squared. Make sure you hit the equal sign on your calculator before dividing, or you might not get this answer. Now that we've already talked about acceleration, we will also briefly talk about deceleration. Deceleration is just a negative acceleration. The other way you can think about deceleration is that the object is slowing down. As you can see in this picture, with each second that passes, the car's velocity is 4 meters per second less, and the distance it travels per second is also less. It is assumed that positive acceleration is the direction the car is moving, and negative acceleration is the opposite direction behind the car. Let's take a look at an example of deceleration. You are driving and a tractor pulls out in front of you. You take your foot off the gas and coast at a rate of negative 5.5 meters per second squared for 4 seconds. Find your new speed if you were originally traveling at 24.5 meters per second. First, we will write down all of the data that we were given. The initial velocity is 24.5 meters per second. The acceleration is a negative 5.5 meters per second squared. The time is 4 seconds, and we are trying to find the final velocity. The basic equation we will use is delta V equals A times T. In order to find the working equation, we need to solve the basic equation for V sub F, our final velocity. To do this, we will add the initial velocity to both sides, giving us V sub F equals V sub I plus A times T. Next, we will substitute in the information we know. This gives us v sub f equals 24.5 meters per second plus negative 5.5 meters per second squared times 4 seconds. Make sure you don't forget the negative sign and the acceleration, since we are actually looking at a deceleration. This should give you a final velocity of 2.5 meters per second. This concludes our lecture and examples on acceleration.